Now often the most convenient way to actually calculate with vectors is to break them up into components. Now to do this we need to define some axes. So let's say we had a vector, something like this. We can define coordinate axes. We're going to need an x-axis, a y-axis and a z-axis. Now you can actually define them any way you like. The physics will not change, you'll get the same answer. The answer might look different, but it's going to be the same in terms of what it means for the real world. So that means normally it's best to pick your axes for convenience. For me personally, if I've got no particular reason to do otherwise, I will pick an x-axis horizontal to the right, a y-axis vertical, and a z-axis sticking out of the paper or screen towards me. And what you do is you write the vector as its three components. So it'll be the x component of the vector, the y component of the vector, and the z component of the vector. Now how do you calculate them? Well, let's say our vector was along the x-axis and had some length, the modulus of v, the magnitude of v, whatever we want to call it. Now in that case the vector is along the x-axis, so vx is going to be positive, vy and vz are going to be nothing because there's no component along those y or z directions. So in this case the vector v is going to be this length here along the x-axis, which is just mod v, the length of v, 0, 0. And how about if you had a vector along there? Let's call that a. In that case you'd write a. It's got a component along the y-axis but nothing along the x or the z-axes, so that will be 0, the magnitude of a, the modulus of a, 0. So if your vector lies along one of the axes, it's pretty easy. But what if it doesn't lie along one of the axes? Let's say we've got y, x, z, and a vector that's in the xy plane. Let's call that b. And let's say it's at an angle theta to the x-axis. Now what are the components? Well, the component along the x-axis is what you get if you drop a perpendicular line to the x-axis. Likewise, the component along the y-axis is what happens if you drop a perpendicular line, so at right angles, down here. So that is the x component, and this is the y component of the vector b. How do you work them out? Well, you use trigonometry. This is a right-angled triangle. So if you remember the definition, this is the hypotenuse. So the hypotenuse is the length of b, so the hypotenuse is mod b. This is the adjacent side, and that's the opposite side of the triangle for the angle theta. So if you remember, sine theta equals opposite over hypotenuse, and cos theta similarly is adjacent over hypotenuse. So in this case, bx is the adjacent, so bx is the adjacent over the hypotenuse, which is the modulus, the length of the vector, equals cos theta. So that's adjacent over hypotenuse. So the x component, bx, is just mod b cos theta. How about the y component? Well, the y component is this length here, which is the same as that length there. That's the opposite of this right-angled triangle. So we can do the same sort of calculation, and we find that by equals the length of the vector times sine theta. So all in all, the vector B is mod B cos theta, mod B sine theta, and it's got no component along z, so that's just 0. And you could do similar things if your vector was in the x and z plane. Again, it depends whether your angle is this angle or that angle, but you can use the definition of sine and cos to work out which component is which, and work it out all similarly. If your vector is in general in sort of 3 dimensions, it's actually not in the xy plane or the yz plane, but actually in the middle somewhere, you can do the same sort of thing. You have to break it up stage by stage. So if, for example, you had a vector that was coming out here, and it came down to there, and then so you've maybe got an angle theta here and an angle phi there. What you do is first of all you break this into the adjacent and the opposite, which is the y component, and then you take the adjacent and itself break it into its x and z components, again using trigonometry and the same trigonometric equations over here. So you can work out pretty much any vector into components by using those